All right, guys. So thanks for joining us for our first virtual meetup. Actually, if I think about it, this might actually be our year right right now. I think April was our first meetup. I'd have to actually go back and look, but that's still pretty exciting that we've been doing this for about a year now. Today, we're going to be talking about optimizing for developer experience in a cloud native world. So Drew Corey is going to be joining us from Contino. He's going to be talking about that. We're going to do a little bit of updates like we normally do. He'll do his presentation, and then we'll hang on, we'll discuss and do a little bit of wrap up and talk about any of the projects that anybody wants to talk about. So a couple things that we want to talk about is we hosted, I say we, as in the CNCF, hosted the Cloud Native Summit. I helped them out with that. If you want to go see, it was an 8-hour long video, long stream. So we talked about Kubernetes updates. We talked about Vitas. We had a bunch of Containerd, Fluentd maintainers on there talking about what they've been working on, what they're doing. Prometheus maintainers are on there. So go ahead and go check that video out. I think they're working on getting it cut up so that's just the actual presentation. So that was a lot of fun. Go check that out. Looks like I picked out 2 blog posts from the week. Looks like Argo and Dragonfly got accepted into the CNCF projects for incubators. I thought when I saw Argo, I thought for some reason it was Anthos, but it's not Anthos. It's for maintaining Kubernetes tools and running jobs and applications on Kubernetes. So it's something you can go look at, see if it helps with your workflows. And then with Dragonfly, this one's around managing cloud native images and file distribution systems. So that one looks real interesting as well. So go ahead. That one's been pulled into, was accepted in the sandbox. Yeah, both of them are on the incubator project. So for everybody who may or may not know, to get a project to be in the CNCF, you have to go through certain stages: sandbox, incubator, and graduating. They have certain technical requirements that the technical committee looks through and checks, and if you've met those certain requirements like security, release cycles, things like that, you can get pushed through into the graduating project. So you can see all of those underneath graduating and incubating. So you got a whole list of them there. And you go read through all those projects. So those are the 3 things, 3 updates I just wanted to go ahead and walk through. Does anybody have any projects that they're working on that they'd like to talk about, or if they have any updates? I know Contino's always hiring, so always got that out there. Is anybody else, looking for a job, actually hiring, or if they have a project that they're working on that they want to give an update on? You can unmute yourselves, and then you don't have to be on video. That's your choice. Drew doesn't have a choice. But if anybody has anything that they want to talk about, go ahead and unmute themselves, raise their hand. No? All right, well, that's easy enough. I'm going to go ahead and stop my share, and I'll let Drew take over the show. All right, Drew, it's all you, buddy. Go ahead and go in there.
1, 2, 3.
1, 2, 3.
Cool. Let's see how I'm going with my sharing the stuff that's popped up. Cool. Can everyone? That's loading for me. Can everyone see the main screen?
Yes.
Yep.
Cool. Optimizing for developer experience in a cloud-native world. That's a tongue twister. So let's start off. Hi, I'm Drew. Working with Contino as a tech principal. I've been with for about 7 or 8 months now, and about the same back in Australia, back home for me. But I'm really excited to be here, both virtually with all of you and in America. I'm really enjoying the time. I thought I'd tell you a little bit about me. I know we've had a bit of a chat before this, but basically started off as a bit of a web developer. I got really curious as to where my code was going, which servers they were running on, and I learned about this thing called the cloud and DevOps. And back then, Puppet. Then I followed a journey into consulting and had a lot of varied experience trying to essentially optimize developers' experiences time and time again in various projects. So this is pretty much what it's like to be hanging around me. Thought I'd share one of my favorite XKCD. So if you ask me to do something, I'll definitely do it. But it's just about when and how, and trying to over optimize it really. And that's the theme for today. So hopefully we can have some fun with it. I've got three main things we're going to go through today. So I just want to start with a level set and a definition of cloud native, because I don't think you can do a cloud native or serverless talk without trying to define it. So we'll see if we're on the same page for that. I want to go back in time, so I want to do a bit of a journey of how we started with cloud and how we got to serverless. If you guys let me know, we've got a bit of a small crowd here, so definitely let me know if you want me to go faster or slower through these things. I want to finish up with really some tips and techniques on optimizing for developer experience and how that applies specifically to serverless, and take you through some examples, some example repositories, and applying that in a real life scenario. So if that sounds good, give me a wave or something for the people on the video. Thumbs up. Yeah, cool. All right, we've got buy-in. I love it. All right, what the fudge is cloud native? Why should we care? So this is going to be my explanation from what I've seen. So we've got, if we start off with infrastructure as a service, that's your networking, your load balancing, your Lego pieces. We have to do a lot of work and assembling. So that's infrastructure on the far left. If we look at the far right, your SaaS, if you use Salesforce, anything where it's all managed for you, you're buying the product, you're not deploying your own stuff. This kind of, you could call it a sweet spot, or this spot in the middle is some sort of combination of, let's call it serverless, platform as a service, functions as a service, or backends as a service. If you haven't heard of some or all of that, I'm going to walk through what they mean, where these acronyms came from. But some of them are probably already familiar. Let's zoom into cloud native, because that's what we're talking about today. So for cloud native, really, I like to think of it as the really obvious stuff, serverless, Lambda, functions as a service type thing. You see some clouds are less creative with their naming conventions, Google Cloud Functions, Azure Functions. These are your bits of deployable code where the rest of it is really managed for you. On the far right, we've got the platforms that you might be aware of, like Google App Engine, Kubernetes, Beanstalk, Heroku is another really popular platform, right? Where lots of things are managed for you, but you have some flexibility still. So it's very, very different from just straight infrastructure as a service. Just making sure I'm checking my messages. Yes, just like James said in the chat, please feel free to stop and ask me questions. I don't have like a super long 1 hour presentation for you, so I've got plenty of time to interact. So definitely do that. I've been promised some heckling from some people I know on the call as well, so can't wait. Cool, so we've got serverless, we've got platform, and in the middle there we've got backends as a service. So this might be like your DynamoDB, we've got here Contino, AppSync, and so these are a little bit different from your functions as a service. They're providing highly scalable backends, but they're a little bit different from platforms per se. It's just an extra form of categorization. Cool. Oh, almost went too quickly on the animation. So as a roundup, granular control for the infrastructure stuff on the left. Lots more features, maybe more specialized with the SaaS stuff on the right. Where we know that platforms allow you to focus on writing code without the underlying infrastructure, which is great. Serverless, I feel, sits somewhere in the middle there. And specifically, functions as a service being our business logic, and the backends as our service, giving us highly available backends that we have barely any config that we really need to do. So you might hear people talk about planet scale, or some scale that kind of supersedes the scale you might get in your own homegrown managed service. I think it's just one more diagram for the level setting, but if anyone's seen the pizza model, this is just another way of looking at that. So just like we've talked about in all the other slides, you can see here in the differences between the services based on how much it's doing for you. On the far left, you have to do everything from networking to apps. On the far right, everything is done for you. With serverless, depending on what we're talking about, containers, platform, functions, backends, there's some various levels in the middle where it's probably more than the virtualization, but less than the application that's being done, managed for you. Cool. So I've defined cloud native. We all know what it is. I didn't have anyone talking back. No questions asked, so we must all be on the same page. I got a thumbs up. That's positive. 2, 3, so many thumbs. Cool. So let's take a step back in time. Think really hard about what funny image I would probably use in the next slide. I can tell most people are muted, so you're all laughing in the background.
I couldn't say anything. I've seen the slide.
I got a not a nod, but a shake from Thomas. I think it is a head shake. Yeah, not impressed. There's more jokes to come, so stay tuned. Cool. So I actually found this blog post by Hacker Noon quite a while back. I think it's probably about a year ago now. And luckily, I saved some of the content because I wanted to share it with you today. But when I went to the link, it was 4A4ing, so they must have moved it. That means you need to take my word for everything that you see next. Really, you're going to have to believe me. So let's start off in 2010. So if you can think back then to when, I guess we had lots of on-prem, not really in the cloud yet services. So I've got this amazing brand here. They have a database, app servers, a payment gateway, a lot of infrastructure they're managing themselves. They've got network engineers, sysadmins. They've got one software engineer over there writing out the code, typing away on the keyboard. You know, the infrastructure is oversized because it needs to handle the peaks and troughs, and they have a large IT team. So this is not ideal state, right? Oops. So fast forward a little bit to the introduction of the cloud or infrastructure as a service, and you should notice from the previous picture that we have the same infrastructure here, but it's on demand. So maybe we're saving a little bit by only provisioning the infrastructure we want. We've maybe been able to reduce the team size here, so we have much less in our IT team because we've codified, used infrastructure as code, and able to automate a lot of the infrastructure pieces, which is great. We still have our software engineer because, hey, we still need to write software. That's what our business is doing. So if we fast forward a little further to the introduction of, let's say, software as a service, more cross-functional teams, what you should notice here is that some of the infrastructure has now left the core business. It's being provided by the software as a service providers. So we need even less people managing our infrastructure. So I'm really just walking you through more of an example of what could be or what has been. We still have our software engineer. We still have databases and app servers that we have to manage. And if you've managed any of those yourself, it's not fun. Some people might enjoy it. I certainly like offloading some of that responsibility and doing the software developer stuff. For the people that do enjoy some of that stuff, there is hope and there is a lot of fun stuff to do in that area, which I'll explain next. So if we take a look at 2015, let's say onwards, or in the last recent history, here is where we're talking about cloud and serverless. So here's where we're kind of bringing it all home. So this might not be representative of every company, obviously, or the whole company and how it operates, but this is an ideal what we talk about when we talk about cloud and serverless. So not only are SaaS providers giving us certain services that we don't have to worry about, but now we're worrying less about the apps and the databases because we have highly scalable database solutions. We have functions as a service where we can just write our code, our business logic, and our data. We can send that off to the particular service and have that run for us. Now, I don't know about everyone else, but the reality for me is that I don't see lots of big corporate companies and enterprises operate like this. Where they do, it might be in pockets with new products, new features where they're testing things out. So sometimes companies operate in a mix where some teams are like this, but they still have other teams that are a little bit like this. And the older and the slower the companies go, they may still have core services that look like the first picture that we have. Maybe they haven't transitioned fully off on-prem yet. So these aren't like finite pictures that are meant to explain perfection, but really just walking you through kind of what this looks like in terms of where things are living now, where all of our people are. Excuse me. One of the interesting things to note is that we haven't gotten rid of all the IT stuff. It's not like all the IT work has dried up. There's some specialized work over on the right where you might be providing support, deep technical support for these solutions to SaaS products. backends or functions as a service, and there are still teams of people within the company that are focused on building these as well. Are there any questions or any commentary about this in terms of experiences or how you see this playing out in your own organizations and teams?
I get a question.
Go for it.
Why don't you think more larger organizations operate in this fashion?
From what I've seen, culture, people, and maybe let's say politics can play a big role. So how companies are incentivized, maybe for short-term or long-term goals, can play into it. It's also hard, as anyone who's worked in IT or in teams or with people, to figure out agreement. Which path should we take? So we might go down one path. We might not see the rewards, the rewards straight away, and we might go, "Oh, that's a failure." Moving to the cloud was a failure because X, Y, Z happened. We didn't get something right. So it's actually surprisingly easy to take the same patterns that you had, let's say, for on-prem provisioning, especially if we don't upskill teams or anything like that or change culture. It's really easy just to go to the cloud and just use it as an infrastructure as a service, right? It's easy not to understand these things that we see, find them to be difficult, and then try and use them and go, "Oh, it's not for me. I'm a special snowflake. I couldn't use this," or "My regulations prevent me from doing X, Y, or Z." So we can get trapped in old ways, I think. Cool. I like it. I like the question. Okay, so we've defined cloud native. We've kind of gone back in time or gone through time around infrastructure and a service all the way up to SaaS and serverless. So what's next is really I wanted to take a look at what does it mean to optimize for developer experience, and then share some tips and tricks with you, and actually a real example as well that I wanted to walk through. So, what does over a decade of optimizing get you? And that's over a decade of IT and over a decade of myself being in IT as well. So the answer that I have for you is to get you three things, three musketeers. So this little innovation here centers around three tools, actually, the practice of using three tools. And hopefully you're familiar with maybe a few of them. If not by picture, then hopefully by name. So Three Musketeers is really a method to be able to test, build, and deploy your apps from anywhere the same way. And I actually get really excited by this prospect. The key thing that we're trying to do here, I'll explain in detail in the next slides, but the key thing is being able to run the same commands no matter where you are, no matter which team you have. If I have a Mac and you have a Windows machine, and we're using GitHub today, but we move to another build server, all these actions we want to run the same way. We're talking about our build steps, our build, our test, our deploy, and we're talking about this in the context of any sort of software that you're producing. So maybe less so SaaS products, because we don't have a lot of code and deployments with SaaS. We're really here looking at applications that you'll roll your own yourself, even if they're functions as a service, or especially if they're containers or homegrown applications on EC2s still apply as well. So everything we do in our build server and our build steps, we want to have control in terms of the languages we use and the versions we use. And we want to have confidence that whatever's going to run in our pipeline, we want to know that's going to run well. And being able to run that locally on your own desktop can actually save you a lot of time. Now, obviously, times where this might be seen as maybe overkill or too much effort would be maybe a hackathon, especially if you didn't have experience with Docker, or you had a small team or a project that you weren't really going to have live for a long time. But as you have larger teams, as you do more with your pipeline, the consistency, control, and the confidence, all these things are going to be requirements that shoot right up to the top of your list, or at least that's what I found. So I'm going to take you through Three Musketeers, one musketeer at a time. So with no musketeers, you should have this long, arduous process, and you can either read it or listen to me babble on about it, right? If you want to install my app and build it, you need to use Node version 4. Not 3, because it doesn't work with that, and not 5, because I haven't tested that. And if you're on Windows, I can't help you because I tested on Mac, and you get the point, right? I don't want you to have to read a long README, and I really don't want to have to sit every new person down if they're inducted into a project to walk them through some obvious things that I've forgotten about because I started the project 3 months ago. So let's introduce the first musketeer. So by wrapping everything that we want to do in a Docker container, let's say like a build step or a test and deploy step, we can then give this to our users, right? So I might put this in a README or give this to a developer over Slack and say, just run this. Docker run, the container is called container. We've got some volumes that we're mounting, some environment variables, and we're running a command. It almost describes itself in what it's doing. And we can be sure that the container we use is going to operate the same way every single time. So that's great. No longer do I have to worry about software dependencies. So that's kind of cool. But it's never enough for a person like me. We want to optimize. So Two Musketeers is about wrapping this in Docker Compose. And it might not make a lot of sense looking at the simple example, but as our examples get more complex, Compose can really abstract away all of the volume mounting, the environment variables that we need to inject in, and it can make it a lot easier to consume and to read. So that's a real simple win. Compose can also sort of handle one or more services or containers starting up and stopping. So it really simplifies our pipeline steps. But of course, that's not enough, right? So it's called Three Musketeers. So wrapping all of this in what I like to call an interface, right? So we use Make. You might have used it to build software. I know I did back in the day. I think I really only used Make to build Nginx back when I was using Nginx for web servers to lock it down and secure it. But Make can actually be used as a simple target to run a task. So here we use Make to wrap that previous compose command, and suddenly our developers, our consumers, our build tools can all have the Make targets, and we can change what happens underneath without really affecting them or having to give them that explicit update. So that's a very simple overview of Three Musketeers. I wanted to loop back and remind everyone that Docker is the most important musketeer there. That gives us the consistency in the versioning. Our compose and our make on top is a really, really nice pattern that just helps simplify and streamline the whole thing. You may or may not have heard of Three Musketeers. It's actually like really just a pattern of putting these three tools together that, believe it or not, originated in Australia. We're taking America by storm and bringing it to the world. Got a few chat messages here, so I'm just going to make sure I'm up to date. Cool. Oh, we're getting links and everything. Great. And some jokes. That's fantastic. All right. So I thought, too quick. I thought I'd just quickly kind of wrap that up and talk about why I like Three Musketeers. So we're talking about the standards, which you already mentioned. I want to reduce down the explanation that I have to do in the README. I want to standardize on everyone who's using it. And the other thing, which is going to loop into the next topic, is I want to supercharge the development's onboarding. I really want to figure out what's the minimum amount of time a developer can spend figuring out how to use this project so they can start developing in it. So for me, that's the key takeaway. So on that, I wanted to introduce just something a little bit different and a little bit extra. So scaffolding or templating, tools like Yeoman can actually provide onboarding, which is really useful, I guess, more so for, again, larger companies or multiple teams that have lots of projects that start up, where they may spend a lot of time trying to write their boilerplate code with all of their build steps, trying to figure out how to do this for the different projects that they have. So we want a way we can make this kind of self-documenting, get out of the READMEs, and get into some interactive terminals. And to that point, this is kind of what a Yeoman generator looks like. So I, as the developer of this generator, can choose the questions I want to ask that you're seeing there in white. And then as the user interactively responds, or as they pass arguments to do this automatically, for instance, in a pipeline, what we can do is we can take those answers and we can alter the templates that we build on the fly. So I can update the README with the project name. Depending on the default application they choose or what type of application they choose, I can give them a Java template or a Go template for their application to start them off. So there's obviously a lot of work and care that would go into curating the templates, just like you normally would if you wanted to supercharge somebody's onboarding. But this can really go that extra step further to putting a little bit of programming logic into those templates. And when this is a process that needs to be repeated, this is something that can kind of take you leaps and bounds and make sure that people are coding right off the bat. which is really cool. I might pause right there and see if there's any questions for Three Musketeers or for Yeoman. You can tell me how crazy you think I am for trying to have Docker in every single stage of your pipeline.
I'll speak up here. I think it's a great idea. I personally do a lot of this, and kind of my favorite is actually in applications that might not externalize URLs or something like that. Maybe they haven't gotten around to doing that yet. Doing the Docker compose and then using the Docker network there to redirect, essentially hijack those URLs and forward them back to another local container in the compose is usually another cool way to be like, and here I've given you a compose that makes it to where all of this works locally. If you externalize that one URL right there and some other stuff, then we can do a lot more. But here you go, you can work fully local now.
Yeah, it's amazing. I actually do find that it ends up being a mindset, right? Thinking about working locally, thinking about how much you can do pre-commit. That's kind of what I like to think about. So definitely if you can get your build, test, and your deploy happening pre-commit, you can actually save a lot of your mistakes before you even get to the pipeline and wait for your seconds or minutes for it to run and tell you that you either had a syntax issue or an issue on startup. So yeah, particularly if your application can be deployed by containers, there's a huge win on being able to deploy it locally easily.
You find this sort of stuff gets off the ground at newer places when you have more numbers around it? Because right now it's all like it can look attractive and be great, and you can say it's going to save you a lot of time, but usually it's hard to get adoption unless you can quantitatively prove here's your overall cycle time. You're going through all these steps that are a lot of waste. Here's how I can shorten it. Have you had to do that sort of analysis?
I actually haven't had to do that exact analysis. It's typically, I find it being an easier sell, especially when there's not a lot of investment straight up, like being able to take something that's existing and either uplift it or better still on a new project, just starting with one of these things. It can be quite light touch if you just choose one piece. So usually it's just about getting the trust and the buy-in to try it. And if you can break it down into a smaller piece, like, hey, you're about to start a build of this new piece of software. How about I show you how you can run the same Gradle command, but just in a Docker container this time. So that works, and also just layering it on. So starting with the Docker, and then later worrying about adding compose and make so that you don't overwhelm people.
Yeah, that's awesome. Looks like you got a question here in chat.
Great. All right, let me look. I'm not familiar with Yeoman. What would an alternative to this be? I'm actually not sure what an alternative to Yeoman would be. Yeoman really just templates files for you. I might have probably used Ansible myself and done a bit of a homegrown script to generate the files. Yeoman's a little bit more specialized, and it's kind of made for scaffolding for web applications specifically. And it's got a lot of reuse in scaffolding for build pipelines. So I'm sure there's some specific competitors, alternatives to Yeoman, but I don't know off the top of my head.
The thing that comes to mind when I'm thinking about that is if you use Open API, there's generators for that. So if you have an Open API specification, it will generate servers and clients for you, but that's about the only thing I could think of.
Another project similar to Yeoman is called Cookie Cutter. That's literally the name of it, and you can configure that for repos too. And it's just generic, like find and replace. I think it's similar to like Ansible, driven by Jinja.
I remember seeing Cookie Cutter now that you mention it. That's really cool. Yeah, so the concept itself though is really simple. The most simple iteration of this would be creating a Git repo with your files in there and asking your developers to copy and paste those files. It's literally what this is: copy and paste and then replace some key elements. So the power really is in sort of wrapping all of that up. So you just asked a few questions and you get something that looks much more like what you're wanting to end up with. Cool. Alrighty, I think I've got a little bit more. Let's see what else there is. All right, so we've defined cloud native, we've gone back in time, we've talked about various methods for optimizing developer experience. I wasn't sure if I had an example for you, and then I remember yes, I do have an example. I'll look back into my GitHub, and I not only had a Git repo, but also a blog post about automating Google App Engine. So a Google App Engine project that's sitting on, I guess, platform as a service, that's using Musketeers, and we've got an example that we can run through. So I'll try and share these links afterwards, share these out with James or whatnot, but I'll be on the screen there for a while as well. The example we're going through is the Google App Engine demo. And you've got a little drill in the corner there to help you along on this journey. So if you want to pull down this, this repository, the first thing you could do is a Docker Compose up local. And I actually wrote this repository so long ago, we're only using 2 Musketeers. So you'll notice I'm not using make yet. I've been a little bit lazy in not updating it. But this repo is primed for a 3rd Musketeer and for wrapping this up in make. Great news is though, if you were to run Docker Compose up local, you're going to get this. You're actually going to get a server starting up with a mock Google App Engine platform with my application from this repository loaded up. You can hit it in your browser at that port 8000 that we have there, and you can start interacting with this application locally. So when I discovered Google App Engine, actually I discovered it many years ago before it was as polished. But when I rediscovered it more recently, probably about a year or so ago, it was very impressive, the amount and the extent to which you can mock things locally and have it to be so similar and so like for like as the real Google App Engine platform is. So it kind of helped me along this journey of the local development. So that's one command. We get our local server, and you can actually have this sort of up and running while you're editing the code. You can have your code sort of mounted into this container so that as you're updating your code and doing local dev, you're seeing the changes and updates. And the next thing you're probably going to want to do is a deployment. Now, it kind of wasn't enough for me to like go into Google and click around and create a project in Google and the permissioning and whatnot to house my application. I really wanted it to be a one command sort of deal. So Docker Compose up new deploy, assuming that you've got your Google Auth. And from memory, apologize because I haven't run this for a while, but from memory, I had a pop-up for the authentication if you hadn't pre-authenticated to your Google account. This command is actually going to go create the tiny bit of infrastructure necessary in our platform, and then take the code from our repository, send it over to Google, and ask Google to deploy it. Google will do its blue-green deploy or rolling deploy, and after some short minutes, you'll actually have your application highly available and running on the internet. New deployments are really just, I had to break the bank and go for 2 commands here, I'm sorry. But when we're doing new deployments, we need to feed into it what the ID of that particular deployment is, because you can deploy to many different projects as you please. And so you get that from the output of the previous command. You can put that in your terminal and you can run, redeploy. And maybe I can wrap this in make and finally achieve my 3 Musketeers Nirvana. Cool. That was super quick. That was the demo. I can obviously go into more detail. We can go question time. I had some of those links there for you, but I don't have any more slideware. I accept rounds of applause as well.
So Drew, how difficult is it to teach development teams this process? I'm sure I'm assuming you've done this before.
Certainly have, yes. Had quite a little bit of experience in this. To be honest, what I found is it really depends on when the people that you're trying to teach, how willing and open they are, and how much they trust in what you're trying to teach them. So if they feel like they don't have enough time, or they're not interested, or it's not going to be valuable to them, or if there's some sort of reason why they don't want to be working with you, it can be really difficult, right, if you don't have the buy-in. Assuming that you do have the buy-in and you're willing and able, we've actually found that it's not awfully difficult to teach the concepts and to get it set up. I will say though that there are some interesting edges around Docker and permissions and volume mounting and environment variables. So it's not going to be like a walk in the park if you haven't written a line of code yet. if you can't copy and paste some examples, if you haven't gone through the battle scars of putting that together and you can't kind of walk someone through it. So there is a little bit to it. It's not just something that you sort of get for free and don't ever have to think about again. Depending on the complexity, and if you want to take this to multiple teams and have a lot of reuse out of your steps, let's say that you want to do code quality scanning and security scanning, and you want to develop all the steps necessary to do those, let's say in a big enterprise. You're going to need to think about how you want to invoke these build steps, what functionality you want, whether you want to have some of these steps long running or detached and coming back with a response for you. So, I mean, if your setup and requirements are complicated, then it can be a bit of a journey. If we have a look at something like the Google App Engine repository, which is quite straightforward, and we're looking at like a serverless platform, this is where it gets a lot simpler, right? So if we look, it's been a little while, my Docker Compose is about 34 lines, and that includes local development, deployment, and new deployments. This is really my whole pipeline. What I had to learn the hard way, which actually wasn't even Three Musketeers, but was more of the Google platform, is that I needed to do things like set certain flags so my app would work properly, permissioning inside of a Docker container, because we kind of go that one level deep. Things like making sure that ports were open so I could reach out of the container to the host. These things are difficult at the best of times, but if you have not a lot of experience in port mapping around containers, port forwarding, and if you're using old school Docker, where there's the intermediary because you're not going native, lots of these things can trip you up, particularly if you don't have the experience. Google was interesting in its permissioning. Normally Google pops up its permissioning in a browser, but because it was running in the container, it couldn't do that. So I had to alter a little bit how that happened. I could still make it work, but it was a bit of a learning experience. So there'll always be lots of fun things to do. It's not going to be really about like how do I use Docker, but how does using Docker apply to what I'm doing with Google App Engine, or how I'm trying to expose a port on my host. Those will be the fun things that you have to think about.
Can you talk more about how you use Make? Like what's the role that it fills? What are the different pieces?
Yeah, definitely. Let me see what I've got here for you. This is probably an example of some actual code, which is really cool. So the whole concept here is that you can kind of build up and move away from your README into your Docker command, into your Compose command. We're trying to abstract away some complexity there. So Make is really used in its most basic form just for targets. So Make targets like Make Echo is really just, think of it as an alias or a shortcut or a target to this command. So I either have to tell the developer to copy and paste this in their browser and get it right, or I can tell them just run make echo. And then if I choose to change the compose command in any way, I don't have to reteach someone, oh, not the compose command with --rm. We changed that a week ago. So suddenly I'm just saying, hey, if you run make echo, or let's in this case make build, then I promise you that make build will always build your software. So it's really a promise, a convention, an interface that, as a developer, think of it really as an interface to help abstract away all the changes that you're going to do in the pipeline.
I mean, it's basically the same reason that they use make when you're building C files, so you don't have to remember all of the options and command line switches. And if your build command's like 3 lines long, you do make build and it takes care of it for you, right?
One of the other benefits is on all of my repos, if you type make, you'll actually get a help that responds back with all the possible make targets. And then so it then becomes self-documenting, it becomes your entry point. And if you're doing this with multiple teams, it's really cool because one team can be a Java shop, the other one can be Python and Go, one can have serverless and one can have EC2 servers. But the make standards are all the same. They can be the same across those repositories. So you do potentially get that added benefit of being able to go between teams and just have to learn less as you go.
Have you seen I'm a big fan of Make, and GitHub. There was somebody that worked there. It was like GitHub or Scripts to Rule Them All was like the blog title. And if you look for that guy that worked for GitHub, and I think did some development for like Homebrew, followed a pattern of various specifics, like exacting script names in a directory, no matter what project it was. And I haven't seen a follow-up post, but it proliferates to a lot of bash, whereas Make just takes away that problem and is already kind of fit for that job. Could almost write an article on all of this, like solid design principles, and how to achieve that with this.
Funny you mentioned that, actually. There's probably some of that on the Three Musketeers website, though I really want to, if you can find and share the post you're talking about.
Yeah, I'll find that real quick.
So the Three Musketeers website goes through some patterns and really how to use each of those patterns. But specifically for Make, if we go to Make, it has a lot of tips that are specific to using Three Musketeers and some conventions around when you use underscores for certain things. You know, if you've never used Make or haven't used Make a lot, the reason why you want to use phony, environment files to simplify some of this stuff. So if you're kind of going down this path, definitely spending some time on the Three Musketeers website and going through like the Make conventions, I found to be really helpful. I personally need to go revisit the environment files concept, because that one's quite powerful, and I keep forgetting exactly how to use that in more complex scenarios.
So the Three Musketeers pattern specifically states Docker Compose. How does this, work with or work with like Kubernetes or other orchestration tools?
Yeah, this is an interesting question. I actually get a lot. Well, we can delve in. I'll delve into two things. So the first one being that there are lots of different patterns. So we showed you Make, Compose, and Docker. Although you might have different patterns that that might not include Compose, or might include something different than Make. Let's say as an organization, you realize that you use Windows a lot, and it was a bit too tedious to have actually Windows running. Well, I can't find my example. Probably a bit too tedious to have Make for your Windows people. You can replace these concepts because it's just a pattern and an idea. The one thing I would say, though, is that we're not really talking about the deployment, the application architecture deployment itself, but rather the tasks that you run to do the deployment. So your application might be a Kubernetes deployment. It might be the App Engine deployment that I showed earlier, and that's actually quite different than the build command. So, for example, my deployment, if we look here, my deployment is actually a Bash script that I wrote in this case, and that script, if we can find it, you can tell I love my little Bash scripts. That script is just an API call to gcloud, right? So it doesn't matter what my app architecture is or how I'm deploying. I can deploy using Helm, using Kubernetes. The compose part doesn't apply at this level. It's more so at the build steps. So our Docker compose file here is really to orchestrate our build steps, or our build, test, deploy steps. Does that answer the question?
Yeah.
It's actually quite a common one as well, because I think every time you hear compose or think about compose, it's really fair, right? The traditional thing that you're thinking about is, oh, I'm deploying my application. But what we find actually is we're kind of repurposing compose to run tasks for us in a way that ends up being quite nice in terms of readability. So again, I have to go to my README. I can kind of come here and see the makeup of my build steps.
Drew, I just thought of something. You could replace Compose with Kubernetes and Docker, which is Kind. So you could just have it spin up a Kind cluster and deploy your application. That would be interesting.
I've never really thought of that.
Yeah.
I think the cool part about that is your interface would still stay the same because you could under the hood change, compose out for kind for Minikube if you're feeling quirky, but you just say make local, make something like that. It'd be you're as long as now would you go as far as adding commands to say Bootstrap and make sure dependencies are present so that is Docker present, is kind present, is do those dependency checks, and if not, try to auto install them for them, or
Typically don't, but funnily enough, at a recent project, we didn't have Compose installed on the build agent, but we had it in the artifact store, so we could easily obtain it. So I had a choice between raising a request and waiting a few weeks to have it officially installed on the agent, or adding a make target that was a prerequisite, and if it couldn't find Compose, it would download Compose, put it in the right spot, and use it. You can guess which one I chose.
Yeah. Has that ticket worked yet?
Actually, the other method works so well, I didn't need the ticket. So I'll get around to it. So yeah, I mean, the answer is kind of what works for you. And it's super simple, right? It actually only took me, probably all of 15 minutes. Once I realized we had Compose available, I'm like, oh, cool. Let's just make a target for this and throw that in, and I'll deal with the rest later. So it's quite nice to think of that dependency and add in whatever you need when you do have a dependency, and makes really good at calling other targets when you need to chain them together.
So a lot of boilerplate can get generated here, and a lot of apps can have like a lot of the same compose file or whatever, or make file. Do you find yourself in using this? Do you find yourself trying to centralize to the make being like clone this other repo that has all of that in there in a specific version, rather than having it all explicitly declared in each project or repo?
Yeah, that can be a tricky one answer as well. The method that I usually settle down to is versioning every Docker container kind of as its own sort of living SDLC. So every time I want to do a bit of functionality that adds on to a previous step or container, it'll end up having its own life cycle. So for example, if I want to do scanning with SonarQube, and I need to build a container with the appropriate requisites on there and the right inputs and variables, I'll actually roll my own container for that if I can't find one present. And then that gets its own life cycle of versioning, and then I can use it in this way. It does mean that you end up having quite a few containers and utilities that you have to manage and version. So it kind of is a bigger payoff when there are bigger teams and more reuse when there's reuse at stake. If I'm starting early in smaller teams, I usually like to start small, have it all in the one repository, and deal with that problem as I face it. So as I'm trying, I find I keep changing one little file, but there's 3 or 4 or 5 concerns in that repo, and I go, okay, well, now I kind of want to be able to abstract it out, do more testing, then it grows and things have their own repositories. Cool, I love the questions. How many people are using something like this or some parts of this already?
I've used something pretty similar, work I've done. It actually got kind of complex for what I needed. I was setting up different compose environments, but what I eventually needed to do was to template out a YAML file to fill with variables in order to stand up different environments very, very quickly, because I was switching between different configurations that I needed for testing purposes. But it started off as Docker, Compose, and Make.
Oh wow! Okay, look at that. You've been doing Three Musketeers the whole time.
Yeah, but I'd never heard the terminology for that before. So
Yeah. So it's actually really just the promotion of a pattern that a group of people discovered, that it turns out it's not as unique as you might think, right? People around the world have discovered this pattern. So it's really giving it a name, helping people explain it when they're trying to explain it, and sort of convince people that this might be useful for them. And then just having a home for some examples and some patterns. And like we said, if you try and introduce this and you've only done pockets before, you kind of want to try and take some of those lessons learnt and say,
yeah.
plus, how cool is this little logo?
They're all sharing the same hat.
Yeah, they're three musketeers.
Uh,
Little musketeer hat.
All right. Well, if there's no more questions for Drew, thank you, Drew, for speaking and coming and talking to us at our first virtual meetup. Go ahead.
I was just saying thank you very much for having me. Appreciate it.
Yeah. All right. Well, we've got a couple minutes. If you guys have any questions about what we've talked about, I'll make sure to give you Drew's phone number so you can call him at 3 o'clock and talk to him about Three Musketeers. I'm sure he would love to have that conversation with you.
The funny thing is, they would.